All right, so this week we're going to do math and electricity. That's it. I'll take the whole week, and we'll be done with lecturing. There's only 2 subjects I have left to go. There's a lot of math on the FAA tests. There's the math section, and then they put a lot of math in a lot of other places. Power plants got math. Electricity's nearly all math. It's just a lot of math. That's the bad news. Unless you're into math, then that's the good news. The good news is, if you suck at math, you won't when you're done. I will show you how to be really good at FAA math. It's very, very simple. There's a few little tips and tricks. Once you pick them up, it's like, wow, okay, that's super easy. So, but I told you I was going to start at the beginning and work my way up. So when I say beginning, I mean beginning, because we don't want anybody left behind on this whole math thing. But you should have, it's like the only PowerPoint slide I have here, is this slide. They don't make this calculator in an online or a workable version that I can upload and do it at the same time, so I have to just talk you through it. They do make a calculator, or Texas Instruments does, that will allow you to do that, but then you would have to pay more money for a calculator. And this is one of the cheapest calculators out there. It meets the FAA requirements. You can walk in, take your FAA test with this calculator. You can use it on every single test I will ever give. You can use it on all the other tests. So when I take, if I were you, and I'm not, if I were going to take a test anytime I would get ready to any test in the program, I would have a piece of scratch paper and this calculator out, ready to go. Because that's where I am. I like to draw out questions and stuff. Oh, how about word problems? How do you like word problems? FAA's got a ton of them. There's a trick. Once you know it, they're the simplest thing ever. So they follow the same formula for every single one. Well, it's 2 formulas. One is just an inverse of the other one. So it's really quite easy. So we're going to get very, very familiar with this calculator. Does everybody have this calculator? I told you if you don't, I'm okay with that. Just don't ask me about it. You're on your own because you chose to get a different calculator. You cannot use a calculator that has a memory function. FAA won't let you do it, so might as well get used to not doing it. I don't see that it would benefit you in my class. I don't really make you memorize any formula, except for ones that we use so often that, and they're so simple that it's like, just remember, it takes you less time to memorize it than it takes me to write it. So, right, they're just simple ones. When we get into AC electricity, the formulas, there's so many of them. There's so many formulas. And what I do with that is right before the test, I just bring up a blank, I'll bring up that and I'll ask you guys, what formulas do you want for this following test up on the board? And I'll write every formula you want up on the board. So you don't have to memorize formulas, but you have to know how they work. Let's go back to that. All right. About that. So we're going to start slow. Oh, let's say math. There are 76 possible math questions on the FAA general exam. Out of 76 questions, you will likely only get 5. This does not count all the math involved in any other subject areas like electricity. Many of the questions are word problems. No need to fear, because by the time you finish 309 and electricity, you should be able to get 100%. And if I didn't mention it or if you forgot, your oral practical is based on what questions you miss. So if you miss math questions, guess what your oral practical will have on it? Math. So there's an incentive to get 100%. All right, first thing we're going to talk about is terms. So 1, math. Hey, terms. Because like most things, sometimes you don't just come right out and say what it is you want. Like if we had one of those, that would be a plus sign. But it wouldn't say plus this number plus that number. They'd call it addition. Sometimes increase or the sum of 2 numbers. So you have to remember that. So the sum of 2 numbers. As opposed to that, which of course would be subtraction. And what would be a word problem way to put that?
Difference.
difference. Very good. Difference between two numbers. Where's this in multiplication? And what's the fancy word for that one?
Product.
Product. Okay, now you see how it would be a problem. If they said, what is the sum of these two numbers or versus the product? You'd be like, sum means what now versus product? So product is multiplication, addition, subtraction, and we have division. Division. I don't think that one comes up. That's quotient. And by the way, the funny thing about division, it wasn't that long ago when I realized that that is a fraction line with two fractions. I'm like, of course it is. So that's where we get the division from. All right, positive and negative numbers. Oh my gravy, does the FA throw out things with you with positive and negative numbers? When we get into weight, when you get into weight and balance, I don't teach the weight and balance part, but weight and balance is a big part of aviation, whether you're a pilot or a mechanic. So you have to be really, really good at weight and balance. And weight and balance deals with positive and negative numbers. And so you have to keep track of that stuff. Because when you're doing a weight and balance, you would have like the weight of something. You don't have to write this down. And the arm of something. This isn't on the test. I'm just explaining weight, arm, and you have a moment. Well, if I removed something after the datum, I would get a negative moment. But if I remove something forward of the datum, it's a negative, and I have negative, negative, and you have to know that that's a positive. Or maybe I add something. See what I'm saying? So you have to have all of this stuff kind of straight in your head and know what's going on. What? Okay. Got it. Whatever it said. I don't really have it, so sorry. So it's important that we do that. Now, just to be completely thorough, there's the plus key, the minus key, the times key, and the division key. Oh, and the equal key. Look at equal. All right. Told you. You're like, hey, this really is easy. All right, positive and negative. Positive. Positive and negative numbers. Well, positive numbers are all greater than 0. Greater than 0. Of course, I would make a 0 like that, so you know it's not an O. And we could shorthand that like this. Greater than, that means greater than. So positive greater than, they're greater than 0. This means greater than. Greater than. That is greater than
Equal.
than or equal to. Of course, we'd have it this way too, which is less than or less than or equal equal to. And negative numbers are less than 0. Less than 0. So lots of positive and lots of negative numbers we deal with. All right, let's talk about basic addition and some rules. Does it do that like every day at this time?
I'll get it shut down.
All right, a positive plus a positive is going to equal what?
Positive.
Always a positive. If I have a negative plus a negative, that will always equal a negative plus a negative equals a negative. Yeah. All right. But what about, let me see. What about a positive plus a negative or negative plus a positive? It depends. Could be either. Because, all right, let's learn how to do this. So, the thing is, some people have test anxiety, especially with math. And if you can overcome that, you just sort of yelled out the wrong answer. People do that. I once had an engineer, and he sat right there. And he knew everything. And I knew that because he told me. And we had that, I was teaching weight and balance at that point. And so I taught him how to do, class how to do the weight and balance. And do that. He's like, dude, I can do better. I know what I'm doing. He failed the test. And he was so embarrassed because he typically did get like near 100% on everything. And he failed the test because it was so simple, he rushed through it. So don't rush through stuff. Use your calculator when you get mixed up. So it's like, so I told you like maybe day one, I will never ever think low of you or bad of you if you grab your calculator to do something crazy. Like if I said, what is plus 10? That means it's the number is positive 10 plus the plus 15. You're like, what's all the plus stuff there? I don't know, right? So you just plug it in your calculator. It's a plus and a plus. It equals, what everybody knows, 25. And a negative 10 plus a negative 10 equals I should have said 15 to keep it consistent, negative 25. Well, how would I do that on the calculator to be completely consistent? This is your negative key right down here. So to do that one I just did, it would be, no, not second. Just that key right there. So the negative key, that's how with the negative key. And then 10 plus 15 equals. Is that what I did? Oh, no, it's negative 15. There. So negative key 10 plus negative key 15 equals negative 25. All right. But if we did negative 10 plus 15, now that could be a little, negative 10 plus 15. That could be, might take me a second, but you can just do calculator. So that's a negative 10 key, the plus key, the 15, 10, 15 equals 5. Okay. Of course, subtracting is nearly the same thing. So if I had 10 minus a negative 15, what is that? Now, I kind of think it like this. When I have a negative minus a negative, I think, well, I'm going to take this little negative and move it, and it goes right there. So I move that to right there, and that makes a plus. So that's really 10 plus 15, which equals 25. But, of course, you could use your calculator, 10 minus, and then the negative key, and you would get the same answer. All right, multiplication. Multiplication rules are a little more. So it depends. So we have multiplication, which is also called what? Product. Did I start this? Yes, I did. Multiplication. All right, we can just do the rules. A positive number times a positive number always equals a positive. A negative times a negative always equals a positive. A negative, I almost said negative. Negative times a positive equals a negative. And that's the rule. That's the way it goes. Let's talk about rounding. Rounding is a very difficult question for me to answer. People say, well, how far should I round? Well, that's a hard one because sometimes we're using scientific notation, and that's so one person's using scientific notation, it's already another person's not. But try to keep it around 3 decimal places is good. So, but it depends on how you're rounding, and this will make more sense later. Like, we use a lot of prefixes, like 1K, that is 1,000. So if I have 1.5K, well, let's talk about rounding. So when you round, you're always going to take the number So 1, 2, 3, 4, 5, 6. And I want to round it to 3 places. 1, 2, 3 places. So I'm going to go right there, underline that one, and I look at the number next to it. And if this is 5 or more, round up. Round up. So round up. So that becomes 1, 2, 4. Right? Okay. Or if I had, we'll make it there. Point. I had 0.1, 2, 3, 4, 5. So my answer becomes 1.124. That's not a lot of rounding, is it? I mean, you're not off by much.
Are you rounding to what 3? Because it should stay 3 then.
Oh, sorry. That's why she had a funny look on her face. 5 or more, round up. I wrote round up, so I rounded up. All right, 1, 2, 3. So that's nearly the same answer, right?
Yeah.
1, 2, 3, 4, 5. 0.1, 2, 3, 4, 5, 6 versus 0.1, 2, 3. It's pretty close. If I have there 1.5k, and I want to round that to the nearest, so I say, okay, that's 5, so that's 5 or greater. So we're going to round up or down? Up. So that'd be 2k if I round. So I'm off by how much? 1k is 1,000, so 1.5k is 1,500, and 2k equals 2,000. So how much am I off now? 500. So if you said, well, yeah, but you always said to round, by 3. Well, that's a bad example, but anyway, you can see. My point is, you have to be careful where and how much you round and what units you're using. But when it comes to like decimals, I'm usually in the 3 places or something. Just don't get too crazy with your rounding. You're going to get a wrong answer, and then you have to explain yourself. It's easier to just do it right.
Do we have to round? Can we just write it fully out?
Well, we use pi an awful lot around here. If you don't want to round, you're never going to get done with your test. I know. I've counted to infinity twice. It takes a long time. So, yes, pi never ends. So you do have to round. Now, if you had like a 5-digit number, do you have to round? You don't at all. If it's in the calculator, I'll just keep it in the calculator. But if I have to write it out, I'll round. But no, you don't have to. If you don't want to. But if you're going to do it right, because I'll hold you to it. So if I had 0.157, I'm going to round nearest hundredths. What is that? 0.16. Okay. Yeah, I can't explain it too much until I explain the next thing. Well, not the next thing, but when we get into scientific notations. All right, fractions. Fractions are fun. We're going to deal with fractions to death. And you're going to be so good at fractions in about 30 minutes that you can go, no way. All right, basic rules. 1. So a fraction is nothing more, well, it's in division, it's a fraction, where you have 2 numbers. This one up top is a numerator. And this one on here is a denominator. And remember that because D is downstairs. And the N is upstairs. I don't know. All right. So anytime you get a fraction, it's basically a division where the denominator I feel like I just misspelled that. Denominator, there we go, with an N. Denominator, not a denominator. Denominator goes into the numerator. Goes into the numerator. All right. It's one thing to say that, but sometimes, like I said, you're doing a test and you get all this anxiety. So I have a favorite fraction. My favorite fraction is 1/2. If you got to have a fraction, you got to have a favorite. And so the thing I like about 1/2 is, what's my decimal equivalent? Because everybody knows that. So if I got sort of confused on a test about some number, I could look at that and go, is it 1 divided by 2 or is it 2 divided by 1? I don't know what the heck this is. I forget now. Well, I know what the answer is, right? I can try it both ways. 1 divided by 2 equals, sure. And 2 divided by 1 equals, so that's the right one. It's like, okay, got my brain engaged now. It's the top one, the division sign, 2.5. Good to go. Told you I was going to make it easy on you. So there we go. All right, let's see. Rules, we're talking about rules. Denominator cannot be 0. And we really don't want to do too much of the improper fraction. Sometimes I ask you to do it. Your answer should not be an improper fraction unless you're asked for it. An improper fraction is where the numerator, is that the upstairs or downstairs? Is equal to or greater than the denominator. Like 4 seconds or 4/4. That would be improper. So don't do that thing. You're going to find that the change fraction to a decimal. You often have to change decimals to fractions, fractions to decimal. A lot. I don't know why that happens. How do you do that? 1. Divide the numerator by denominator. Just like we said. 1/2. Fraction equivalent is 1 divided by 2 equals 0.5. So we just changed it into a decimal. 3/16 is 3 divided by 16 equals
0.1875.
0.1875. There we go. Or use the calculator function. This is where it starts to get fun. Three sixteenths. So if I want to know what 3/16 is as a fraction, I could do 3. I hate you. 3. Yes, anytime you write anywhere up here, it's going to screw it up. 3. Well, we're going to look for this button right here. See that? FD. I write it like that. FD. Guess what F stands for? Guess what D stands for? Decimal. And look, the arrow goes both ways. So if I want a fraction to a decimal, first of all, how do I put a fraction in here? Well, I'm going to do this key right here. See that? I just call it the ABC key. So the ABC will make a fraction. Let's do this. What if I want a fraction that's 1 3/16? I would do 1, ABC, 3, ABC, 16. Let's see if I get it right. 1, ABC, 3, ABC, 16. And it should show you 1, 3, 16. And if you hit enter, it's 1, little u, and 3/16. How cool is that? Now I want to know what that is as decimal. So I'm going, because it's in blue up here, you have to hit the second key. So we're going to hit second. FD equals. And what'd you get? 1.1875. How cool is that? Now you're practically a fraction genius. Almost. Why did I cross that out? Oh, I know why. All right. So what if you had to, so that's how to take a fraction and make it into a decimal. But what happens if you have to add some fractions? What if I just said, well, what's 1/8 plus 3/16? Well, if you had math, you know that it's easier to do it this way than 3/16. You have to, what do you have to do? Find the common denominator. And something like, oh my God, I don't want to find the common denominator. So I don't want to find the common denominator. So you remember how to do that? So what's the common denominator for both of those? 16. So 16 is a common denominator. So this is times 1. So 3 times 1 becomes 3. And this is 8 times 2 is 16. So 1 times 2 is 2/16. And so then you add the 2 and the 3. So you end up with 5/16. Well, how about using our calculator now? 3 ABC 16 plus 1 ABC 8 equals, done? How sweet is that? So you can do anything you want with fractions. Now you know how to enter a fraction. So you don't ever have to find common denominator. You don't have to change it. You don't have to worry about it. You don't have to go from fractions to decimals to fractions, or you can. You just plug it in your calculator and go for it. You can take this with you. FA allows you to use it. No problem. Let's see. All right. This one's a little trickier in a way. All right. If we want to convert a decimal to a fraction, yes, in some ways it's exactly the same as we just did. So if we want to change 0.25 to a fraction, we would simply use this over here. And I said 0.25, so we'd enter 0.25 second fraction decimal equals, and what do you get? 1/4? Right, 1/4. That's all fine and well. What would like 0.24875 be as a decimal?
As a fraction?
There's a fraction, yeah.
199/800.
199/800. So let's just say you were measuring something. And a bolt. So you're measuring a bolt and you're trying to figure out what size bolt this is. And so you use a dial caliper and you squeeze it on this bolt and you end up getting 24875. So what size bolt is that? It's a 199/800 bolt?
No.
What size bolt is that?
1/4 inch.
A 1/4 inch. It's a 0.25. But how do you know that? Well, now you're. How do you round 199/800? Well, I guess you can round your decimal, right? But the point I want to get to is bolts. Remember when we talked about bolts? What's the diameter of bolts measured in?
8s.
I'll give you one more try.
16.
Sixteenths. They're in sixteenths. So I want this answer, 0.24875, I want it in 16ths of an inch. So if I do 0.24875 times 16, it's going to tell me 0.24875 times 16 equals, what'd you get? 3.98. You should got 3.98. See 3.98? Okay, let's round that to the nearest whole number is 4. It's 4/16 because I asked for it in 16ths. So basically what it told me, it's 3.98/16. And now you can just round. And you can do it either which way. I mean, you could have rounded the 24875 to 0.5, but it doesn't always work that way real well. I don't know. My brain works better this way. So I just take that big old number, 0.24875, go, I want it in 16ths. So I'll just multiply it times 16, I get 3.98, and I get 4/16. And you're going to use that a lot when you get into sheet metal. Like, how could I possibly need that in sheet metal? Because in sheet metal, you're going to be dealing with, and this is not on the test, but it's you'll have to figure out the size of rivets to use in sheet metal. And the length is going to be grip plus 1.5D. Oh, 1.5D, that's 1.5 times the diameter. So if I was working with a 3/32 inch rivet and I had a grip, that's how thick your sheet metal is. Let's say I had a 0.032, a 0.032, and a 0.016. What do I get? .08. So my grip is how much? The grip. Did I lose you guys? Okay. You don't have to learn this part, but if I was riveting sheet metal together, I have to figure out how long of a rivet to use to do it properly. Follow?
Yeah.
Okay, that's the formula. Grip plus 1.5 times the diameter of a rivet. So what is my grip? If I had a piece of 032 sheet metal and another piece of 032 sheet metal and a piece of 016 sheet metal, all the sheet metal stacked, how much does all that equal? 0.08. Okay, so that's my grip. Now, I have to add that to 1.5 times the diameter of the river. How much is the rivet? How wide is the rivet? I told you, it's 3/32 because I just picked a 3/32 rivet. So what is 1.5 times 3/32? You should be able to do that in your calculator now because you can do 3 ABC 32 times 1.5 equals, and what do you get? 0.140625. Well, just hit the plus 0.8 equals, and we have this number that's like 0.940625. Everybody got that? Yes? No? Okay, right now it's a random number. Like, what do I do? It's a random number. But what are we trying to figure out? How long this rivet should be. All right, so this is the formula, and I'm just showing you an example of why you need to know how to do this stuff, because you will do this like non-stop when you get to sheet metal. So I need a rivet that is 0.904625 inches in length. Do they make a 0.940625 rivet? No, they do not, because rivets come in lengths of 1/16. You'll notice that it's like half of a bolt. Bolts come in 1/16 diameter. Cut that in half in a second. Yeah.
Quick question. You said add 0.8?
Yeah.
Why 0.8?
Well, because that's what we got here. That plus that plus that is 0.8.
0.08.
0.08?
Oh, 0.08. Sorry.
Okay.
All right. If I make a mistake and you all just thank you, if you just sit there quiet and dumb, it's not going to work. You got to kind of help me out a little bit. So what's the answer? 0.220625. Did you get that?
Yeah.
Okay. All right. So what is that number then? What does that number mean?
The rivet length.
The rivet length. Rivets come in what? 16ths. So I have to actually order it by a part number. So how do I convert 0.220625 to a 16th of an inch?
Multiply by 16.
Times 16. What do you get? 3.53.
So you're going to need a 4 16ths.
All right. So what size rivet do I need? A 3.5. They make them in halves.
Oh.
You'll learn that. But what I want you to know is just how using this process just it makes things not very complicated. Not very complicated. This is an example right there, grip plus 1.5D of a formula you probably will have to end up memorizing, but by the time you use it like 4 times, it's like, how hard is that? And honestly, you can probably intuitively see it. You have 3 pieces of metal. The rivet's got to make it all the way through, and it's got to stick out 1.5 times the diameter. That's all. So that right there is 1.5D. All right, convert fractions. That we got that. All right, everybody good so far? So far so easy, right? It doesn't get much more complicated than that. And you're thinking, I thought I said it was going to get hard. It doesn't yet. All right, percentage. Percentage actually literally means percentage means parts out of 100. Out of 100. All right. So 100% equals 100 parts out of 100. 100 parts out of 100. 90%, that would equal 90 parts out of 100, or 90 over 100. The thing about this is, you have to remember to change the decimal place, and that's all you have to do, but yet somehow we mess it up so bad. So that, just like my spelling, C-H-A-N. Change decimal to a percent. We are going to move decimal 2 spaces. Which way? To the right. And add zeros. So, what do I want to do here? 1 equals what percent? 1. To the right, 100, 100%. 0.9. Actually, we can do it this way. Why is it 100%? Well, because 100% equals 100 over 100. 100 divided by 100 equals 1. So to change it, 2 places to the right, add the zeros. 0.9 is what percent?
90.
1, 2. Put a 0, add a percent. Equals 90%. 90%. All right. 1.25 equals 0.2. 125%. How about 0.335? 0.335 equals 1, 2. 33.5. Trying to think of what the problem comes in. We're used to seeing numbers like this. 33.5, 125, but what is that as a percent?
1236.2.
Which way am I going to move the decimal? Where's decimal? Right there?
Between the 6 and the 2.
Sorry, that's a comma.
Oh.
So what is that? 1,236,200%. Is that the right answer? What?
That's what you want.
Take the decimal, move it 2 places to the right.
Yep.
It doesn't look right, does it? It looks crazy. It's like that is just an insanely large number. So it doesn't look right to us. So we won't do it.
But there's zeros.
Huh?
There's still zeros behind that decimal. So technically you're right. There's just empty spaces there, no?
There's empty spaces here.
Yeah.
Yeah, that's not my point. My point is we're used to seeing numbers like 33.5%, 90%, 125%. We don't see numbers, 1,236,200%. It's not something we see normally. So if I said convert, I tell you this right now, if I said on a test, convert 12,362 to a percent, do you know what everybody's going to put? They're going to put 12.3%. That is going to be the answer I'm going to get. Why am I going to get that answer? Because it looks right. There's no way the answer could be over 1,000,000%. Well, it is. That's just what it is. Things are what they are. So I'm just giving you one of the pitfalls. Yeah.
It's technically an improper fraction, right? Because it's over 100.
Yeah.
That's the point of interest.
But still, I could say that we had a 200% increase in the amount of graduates we had last year. That's improper fraction, but it's still true. So, I rode home last night, Friday, in my car with the windows down, up. Or drove home Friday with the windows up. Tonight, I will roll them down and stick my head out the window with my mouth open. The amount of bugs that I eat tonight versus the other night will have increased by roughly 1,200,000. So it is possible.
Well, technically infinite, but
So I'm just telling you, with the decimal, and you add two places to the, no matter how stupid the number looks, that's still the answer. So it's still what you do. All right. What about, and of course the opposite is true, change. We did that. We just did change percent to decimal, didn't we? Change decimal percent. Change decimal. Change percent to decimal. So we're going to do what now?
it's divided by 100.
Move the decimal two places to the left and add zeros as needed. So 100%, that's 100 points, it becomes 2 equals 1. 50%, 2 equals 0.5. 5% equals 0.05. And 150% equals 1.5. Okay. What if I had to change 5/8 to 8%? What would you do there? You could do 5 divided by 8, or you could do 5 ABC 8. 5 divided by 8 would give you some answer, 0.625. 5 ABC 8, and then second fraction decimal equals 0.0625. So you're going to get 0.625, whichever way makes you happy, and then change it to a decimal, which would be, which way? 62.5. Or multiply it by 100. So either which way, whatever works for you. No matter to me. All right, we good with that?
Yes.
Okay, you're gonna lots of practice with that, and then it'll make more sense as we go. Let's take a quick break.